Welcome to a world where teleportation is not just a dream, but a very real possibility. Imagine waking up in a quiet, remote corner of the world, teleporting to your job in Tokyo and then ending your evening enjoying an opera in Rome, all in a single day, without ever stepping on a plane or sitting through traffic. What used to sound like science fiction is now beginning to emerge as a topic of real scientific research. Technologies that were once the domain of Star Trek fans are starting to take shape in laboratories across the world. This is what if, and here's what could actually happen if teleportation became possible. The most promising way humans might achieve teleportation is through a phenomenon known as quantum teleportation. This doesn't involve physically moving your body from one location to another, but rather scanning the precise structure of an object or a person and sending that information to a different location, where it's reconstructed from different atoms and molecules. It's not about moving matter, it's about transmitting information. The implications of this could be massive. Our roads and bridges could become relics of the past. Congested cities might empty out as people choose to live in more remote or peaceful places, and our ability to explore space could leap forward dramatically. But let's not get ahead of ourselves. First, we need to understand how this works at the most basic level. The core principle behind quantum teleportation is called quantum entanglement. This strange and fascinating phenomenon links particles together in such a way that no matter how far apart they are, the state of one directly affects the state of the other. Once entangled, these particles are part of a shared system. Changing one will instantly impact the other, even if they're light years apart. To put it in simpler terms, imagine you order 2 burgers, 1 beef and 1 chicken, and they arrive in identical boxes. You don't know which is which, but the moment you open one box and see it's beef, you automatically know the other is chicken. That's essentially how entanglement works. Knowing the state of one particle instantly tells you the state of the other, no matter the distance between them. It's weird, it's counterintuitive, but it's real. And it's the foundation for teleporting information. This idea isn't just theory. Researchers, particularly in China, have already demonstrated that quantum entanglement can be used to transmit the properties of particles to satellites orbiting Earth. That's a pretty big deal. But as impressive as that is, teleporting a human being is an entirely different scale. The human body is unimaginably complex. We're made up of more than 37 trillion cells, and each of those is made of countless atoms. To teleport a person, you'd need to scan every one of those atoms, their type, position, spin, energy state, every microscopic detail that makes you, well, you. Once scanned, that information would need to be transmitted to another location, fast and flawlessly. Then, using local matter, your body would have to be reconstructed exactly as it was, down to the position of every last electron. But here's where things get uncomfortable. To do that, the original version of you would have to be completely taken apart, atom by atom, disintegrated. In other words, each time you teleport, the version of you at the starting point is destroyed, and a new one is built at the destination using entirely different material. That raises some heavy questions. Are you still you if your original self has been dismantled? Is teleportation essentially a very clean form of suicide, followed by a perfect rebirth? Quantum teleportation isn't like stepping through a doorway. It's more like copying a document, sending it to another printer across the globe, and shredding the original. Sure, it's the same information, but the paper's different. And when the paper is your body and your brain, the stakes are a lot higher. No one has ever tried to transmit this much data before, and there are enormous technical and ethical hurdles. But the foundation of the technology exists, and we're learning more every year. For now, teleporting anything more complex than a particle is still far out of reach. But scientists aren't giving up, and the possibilities continue to grow. If we ever do manage to crack the code of safe, large-scale teleportation, life on Earth would be transformed in ways we can barely imagine. Picture living on a quiet hillside in New Zealand, commuting to your job in London, grabbing dinner in Tokyo, and sleeping in your own bed, all without boarding a plane. International travel would be instantaneous. Airlines would collapse. Travel visas would become meaningless. In fact, the very concept of national borders might erode, since physical movement would no longer be limited by geography or time. Of course, such a world would come with its own set of problems. Who controls teleportation technology? Would it be free for everyone or available only to the wealthy? What happens to jobs that rely on travel, transport, or location? And what about the philosophical questions? If a teleported version of you wakes up on the other side of the world, is that still really you? These are questions that scientists, ethicists, and governments will have to grapple with if teleportation ever moves from theory to reality. For now, we're still in the early stages. Quantum entanglement is real. Quantum teleportation of particles has been done. But teleporting a human remains a dream, an incredible, challenging, maybe even frightening dream. But with every passing year, what once felt impossible is inching closer to reality. So don't lose hope. The day may come when you won't need a car, a passport, or a plane ticket to see the world. You'll just need a destination, a teleport pad, and maybe a little courage. And when that time comes, we'll be ready to explore a world and a universe that's finally within reach. Until then, stay curious and keep asking, what if?